Hey everybody, it is a delight to be here. Thank you for, number one, coming to the conference, and number two, getting up this early. I know I'm competing with breakfast and other things, so I'm really excited to be here. So let's get going. So I have been working on relational databases since the very beginning of my career. And in that, I have worked with Oracle, I've worked with RDS, I've worked with other databases as well. And so the title of the talk today is Relational, the New COBOL, is meant to be a little snarky and get your attention. So today, though, this is not, as you might have expected, a product pitch. This is a pitch that is going to be about what's going on in the technology industry and how potentially you should be thinking about it. We will have time for questions at the end, by the way, if you'd like. So let's talk about the relentless technological progress that is happening. And I'm going to go back to the very beginning of the century, to when horses were the main mode of transportation. And if you look at New York in 1908, the street is dominated by horses. In 1913, merely 5 years later, there's not a horse in sight. It's all cars. Now think about what we're going through today with the migration to the cloud. Think about migrating from spinning disks to SSDs. Think about steam and water wheels. What causes these technological changes? What holds them back? What makes them succeed? That's what I'm going to talk about today. So now relational is an amazing technology, and just a shortcut, I'm going to refer to relational today as the horse. I'm going to refer to non-relational as the car, and that no punch is pulled there. Prior to relational, there were punch cards. There were various index models and data models, which some of you may be familiar with as I am. They were all very frustrating. And the reason they were frustrating was because the computer systems were not able to process the data in the right way for you to answer the questions you needed to answer. So along came relational. E.F. Codd wrote a paper in 1970 called The Relational Model for Data Stores. It's an amazing paper. I would highly advise any of you in data to read it. And in it, he talked about how we were going to normalize our data. We were going to spread it all out in a way that could be mathematically processed using relational algebra. He talked about how we should never, ever duplicate data in our data stores because at that time, data was so incredibly expensive to store and to access. He even pondered the idea of a declarative language to access all that data. And that was what he called his own little language that eventually ended up in 1978 being released as SQL. Now, this was revolutionary. It enabled multiple vendors to work together. It enabled programmers to develop programs that were transportable between databases for the first time in history. Really big deal. And in fact, relational success detonated a data explosion. If you look here from 2010 to 2025 on the horizontal axis, you will see that the data volume in the world has gone up significantly. And the vertical axis is zettabytes, 10 to the 21st bytes. Millions and millions of terabytes, just to give you an idea. And you see how much is growing there, and it's amazing. Now, the fun thing about this is as I was researching for this paper, I found that IBM did a study, and in 2005, far to the left of this graph, they thought there was less than an exabyte of data in the world, of digital data. And now we think about an exabyte as not even being visible as a pixel on this graph. It's just literally amazing. So relational was quite successful. However, from day one, relational data, data that fit well into rows and tables, was by far the minority of the data. The ratio of 20% structured to 80% unstructured has persisted for decades. And you can see it here on this graph. The orange data is now being measured in yottabytes, which is 10 to the 24th data. And we are generating more and more data. So what does that mean? Do you want to have all your data in one place? Do you want to have your data in separate places? Well, relational let us do some pretty amazing things with all the blue data. All it let us do with the orange data is point at it with a reference or a file reference. Now, I'm a nerd, I'm a CTO, so I get to do stupid math stuff. And one of the things I do is I just switch the graph on the axis on the left to a log graph from linear. And one thing that's interesting is though that other graph looks kind of hard to parse, you can see that the data growth has actually been very, very predictable on a log scale. In fact, it's growing at 23% a year. 23% through your entire organization. Now, Gartner believes that it's growing at 46%, at 42% a year. And that is definitely even more. Imagine that it goes up by 8x every 5 years. Now, why does this matter? Why? Why? I mean, the data, you guys are all running databases. I'm running databases. It all works great. We're asking more of our data. I did a blog post recently. We're asking more and more of our data. We're asking to analyze every byte, every log record, every picture. We're looking at data in different ways using our computers. So it's not okay to only be looking at the data which is in your relational database. So I'm going to let you parse this graph for a second. I'm sure you've all heard of Moore's Law. Moore's Law states the number of transistors on a chip will go up double every 2 years. And that is the top line on this graph. And in fact, you can see that Moore's Law is alive and well today. Chips are getting bigger and bigger, stronger and stronger in terms of number of transistors. But now look at the next graph. Starting around 2004, you can see that log scatter plot of the actual computing power of the chips that were running. And you can see that it took a big trend down. So even though the number of cores is going up, the power of computers is no longer growing as fast. Why does this matter? Cut to the chase. Most relational systems today, and in fact all open source relational systems today, are single primary and run on a single node. They have read-only replicas, no doubt about it, but if you want to actually do writes, the thing that you care about, you can only do that on a single node. And so what that means is that you're fundamentally limited by these graphs. Not only that, and I'll get into this a little bit more later, you all know that if you start with 10 commodity computers, with commodity networking, with commodity memory, and you can, let's say you could use them to 100% of their capacity, and you compare that to a computer that is 10 times more powerful in a single box, that big computer is going to cost more, it's going to fail and cause you blast radius, that you're going to lose your whole application rather than 1/10 of it. It's going to fail more often because it runs so hot, it's an unreliable way to do computing. What you see on these graphs is people pushing quantum physics right to the very edge. We're now down to, I believe, 8 nanometer technology, which is just insane. Quantum effects are starting to take effect on our fastest chips. It's crazy. Why not scale out? Well, that's what NoSQL was invented to do. And in fact, that line 2004 is not there for an accident. Between 2004 and 2006 is when the founders of MongoDB and many other NoSQL founders all realized that relational was losing its ability to satisfy what needed to happen. So Moore's Law stopped being meaningful, and Amdahl's law, which is the law of diminishing returns, started kicking in. You can see on the left, I'm a nerd, you can see on the left, the red line is the power of 2-core chips, black is 3-core chips, yellow is 4 to 7-core chips, and red is these brand new, unbelievably expensive 8-core chips that started popping in. What you can see on the right is no matter how parallelizable a workload is on a single machine, you actually run out of steam at some point. It is incredibly hard to use these multi-core chips. You have to write parallelizable software, you have to have really, really busy, really complicated operating system algorithms, and they're very expensive. So people are doing that today, there's no doubt about it. There's these massively powerful chips that people are using, but why not do something simpler? And so NoSQL, MongoDB, the other solutions out there, was invented to use computers in a different way. So we have computers that are getting less powerful every year than they used to get, and that's the second line. You have data, which we've already talked about, which is growing and growing faster. And you have the fact that we want to do more with our data. This combines to a data flood, which we are not ready to process with relational. Now, look, I've been in relational for 30 years. This is a real game changer for me as I realized this over the last 10 years. at AWS and at MongoDB. And so what are the differences between relational and non-relational in the new world of data? Well, first off, there's the one at the bottom, which is horizontal scaling versus non-horizontal scaling. Most relational stores are actually meant to scale out. Most non-relational stores are meant to scale out from day one. But let's go to the top. In relational, you have to define your schema up front. And changing that schema, all of you who've had Oracle plan changes take down your database, raise your hands. Adding a single field to a database, to a relational database, can take it down. Most people don't know, surprisingly, that the way you add a new field to your non-relational database is you just modify your C or Fortran or COBOL or Python structure and you run your program. There's no database work. There's no command given to the database. The database automatically adapts. It is so much easier to program non-relational stores. Instead of catting together, for those of you who are programmers, a big SQL statement, you just say db.insert with your structure. That's it, one line. So that's different. The other thing, for those of you who are relational nerds, is that when you take a structure and you put it in a relational database, you got to do all the work of parsing it out, and putting in all the right tables, and building all the right indexes and everything else, and you pay that at insert time. With non-relational stores, such as MongoDB, DynamoDB, all the other non-relational stores, you only pay that at retrieval time. Now, that may sound like a bad choice, but the funny thing is, speaking practically rather than theoretically and mathematically, most of that data is never queried by its primary key. The vast majority of it is queried by the primary key of the record that is above it. And so all that work you do to normalize when you insert is wasted work. And it costs you money, and it costs you time, and it makes your database not take inserts reliably. Elliot and Dwight, the founders of our company, wanted to do a very simple thing. They wanted to do 400,000 transactions per second for their ad business. Every time their ad business was 150 milliseconds late, guess what they lost? They lost the ad, because it went to another provider. You cannot have writes be undeterministic in how long they take. Next, we've talked about the fact that when you normalize data, you have to put it all in its own little places. Most applications don't think about data that way. If you're a programmer, think about your structures, think about your nesting, think about your lists. You just want to put that all in one place and retrieve it all in one place. And finally, as much as I personally find SQL a wonderful language to use at the console, it is not a natural language to program in. And so people who are programming in different languages find SQL very painful. So those are all the reasons that we should be worried about relational. As I was putting this talk together, I started doing some math on how much index overhead, how much overhead there was for bigger machines and hotter machines. And I came up with this really strange number, which was that it might cost a penny per year per megabyte to store in a relational database versus a non-relational database. I mean, come on, you all know that the non-relational databases are an order of magnitude cheaper. That has to come from some reason. Well, it turns out that if you multiply that out by a zettabyte, which I've already talked about, you get $10 trillion per zettabyte per year. Now, I debated not presenting this slide because it's like, wow, totally mind-blowing. So then what I did is I took the average enterprise, which might have 10 petabytes of data. That's a standard amount for an enterprise or a business. That ends up to be $10 million a year you're spending extra to store your data in a legacy data store. And that is a number that every company or business or government institution can get on board with. So in closing, I'd like to talk about why some technologies succeed and others do not. Look at the technologies on the left. They still exist today. They're still good. Why? Because they're still useful. Look at the ones on the right. They vanished. In fact, some of you are like, well, holy crap, is Lotus Notes still used? Yes, it actually is, in lots and lots of places. Lotus 123, however, is not. I put that one on here for the fun of it. So this talk was prompted by a CTO I talked to about 2 months ago, who said, I'm having a problem. I talk to a CTO a day in my role, which is kind of cool. And my EA keeps great track of it. And this CTO said to me, I'm having trouble hiring relational people. This person had 75,000 people reporting to them, which is why I can't say their name. And he says, I can't hire relational people out of school. No one wants to work on the technology. And in fact, I asked HR to take all the people who are working on relational databases and look at their ages. They are getting older by 1 year per year. That is a very scary statistic. And that's exactly what's going on with COBOL. So he said to me, is relational the new COBOL? In 10 years, will I be unable to hire talent to do this? So why do technologies switch? They switch because the new one is clearly replaceable, migratable. They switch because there's clear cost savings. They switch because there are compelling reasons and benefits. And between the flood of data, chips slowing down, ease of programming, all of those things mean that we should be heavily considering relational for our new applications. Now, I'm a relational guy, I've been a relational guy for 30 years. A lot of your legacy applications are hard to migrate. If anyone ever says the word easy and migrate in the same sentence, go tell them to go away. It's not true. But it is something we need to consider for our businesses in order to have the right ability to parse our data, the right ability to do the analytics our customers need. So what's going on? We don't know what's going to happen with relational. 20% to 80% is going to continue. That's currently the trend. Not only that, we could just say, hey, let's coerce all data back into relational. I don't think that's going to happen. I put that here as clickbait. We could continue using relational for structure and use non-relational, and we could just join all our data stores. Why would we do that? The non-relational stores now process relations just as well as the relational ones do. The relational stores do not process non-structured data. We could migrate relational apps where it makes sense. And I have written migration utilities for the last 20 years of my career, and yes, it is hard, but yes, it is doable where it makes sense. Not only that, we may find a flood of people offering SQL on top of non-relational stores in order to have application compatibility. It won't be perfect, but it will offer a bridge between the two worlds. So finally, economics and technical flexibility are what are really, really going to determine. Just like cars determined the new future for New York in 1913. Economics are going to decide whether relational is the horse and non-relational is the car. I think it is, and I'd love to chat with any of you about it, either publicly or privately. Thank you very much. I'm happy to take questions from any of you. I'm sorry? Which book? I can't remember. I'm sorry. I have lots of books. Just ask anyone at MongoDB. Which? Oh, the paper on relational. It was E.F. Codd, a model for relational data stores, and it is a very well-written paper. It's pretty awesome. And it's worth reading. The first SQL standard is pretty good to read as well. Any other questions? Okay. Well, thank you so much for your time today. Enjoy the show. And what I'd like to do is give our sponsors, AWS, and each of you a round of applause for making it through COVID and making it here today. Thank you very much. Let's give AWS a round of applause. Thank you very much.
If you could take a minute and fill out the survey about this session, the QR code is on the back of your package. Thank you.